Now we're going to talk about low G and mast bumping. So what does it mean to go low G? Well, how many Gs are we experiencing right now? I think while you're watching this, you're probably sitting in a chair. I'm assuming you're on planet Earth. Therefore, you're experiencing 1 G. That's 1 Earth gravity. Now think about the last commercial airline flight that you took. If the airplane was bumping around a little bit and you felt light in your seat, you were at less than 1 G whenever you felt light in your seat. So the helicopter is the same as the commercial airliner. If it gets bumped around, or if the pilot pushes the cyclic forward into a dive, temporarily you will be at less than 1 G. So why is that an issue in a helicopter with a two-bladed rotor system? It's not a big deal in an airplane. You can go up to 2 Gs in a tight turn. You can go down to 0 Gs, and the airplane's pretty much happy. Not so the Robinson. So imagine you're cruising along like this, and the helicopter goes into a low G situation. At that point, the pilot, the rotor system, and the fuselage of the helicopter are all flying independently. They're not, the helicopter is no longer hanging from the rotor system, and the tail rudder thrust, which had been required for anti-torque, is no longer needed because the rotor system and the helicopter are independent bodies at that moment. So the tail rotor's up here pushing air out this way, so it causes the nose to yaw, and also because the tail rotor is above the center of gravity of the helicopter, it causes a right rolling moment. The right thing to do in this situation is to smoothly pull back on the cyclic until you feel like you're sitting in your seat again. And then, once you've re-established a normal 1 G situation, a little bit of left pressure on the cyclic to level the helicopter back out. It would be nice if that was everybody's natural reaction, but unfortunately, the natural reaction to a rapid right roll in an aircraft is probably going to be to try to slam the aircraft into a left bank. So the way we would do that in the helicopter is with left cyclic, and what happens is the rotor system does respond, and the rotor system moves to the left, but the helicopter is not hanging from the rotor system anymore, so it just stays where it is. And when that happens, an inner part of one of the rotor blades can actually contact the stationary mast that's holding the blades onto the helicopter and cause some damage. In very extreme situations, like in combat in Vietnam with the Hueys and the Cobras, which have the similar teetering rotor system to the Robinson, in some of those extreme cases, the rotor system would actually separate from the helicopter, and the helicopter would be found crashed on the backside of a ridge where a pilot, for example, did a steep pushover with the cyclic. So how do we deal with this in the Robinson? Well, the first thing that we do is we're smooth and we're gentle on the controls, so we don't push the helicopter into a low G situation ourselves. The second thing that we can do is we can avoid flying in heavy turbulence. Severe turbulence will generate a low G situation at random and unpredictable times. And how do you know if it's going to be really turbulent? Well, if it's very windy on the ground, it's probably pretty turbulent up in the air. If we do get into turbulence, we don't have any control about whether we're going to go low G, but we do have some control over how difficult the problem is to manage by choosing our airspeed. So if we're in turbulent air and we slow down to about 60 knots, the helicopter is going to be basically flat, and if we do go low G, the right rolling moment and the speed with which we roll right won't be nearly as large. So the helicopter isn't going to have the tendency to frighten you into making large and inappropriate control inputs. So the takeaway from low G and mast bumping as a pilot is that don't fly in heavy turbulence. If you do fly in heavy turbulence, slow down. And that's everything you need to know to take your first lesson in a Robinson helicopter. Thanks for listening.